Welcome to Lecture 6. In this lecture, we will talk about two problems. The first one is called the coupon collectors problem. And the second one is about the algorithm quicksort. And then we will analyze the performance of these two problems. But before that, we will revisit the harmonic number, and then we will give a closed bound for the harmonic number. So let's start with the first part. So what is harmonic number? So we let n to be a certain positive integer. Then we can define the nth harmonic number. We use h of n to denote this number to be the sum of 1, 1 over 2, 1 over 3, and so on and so forth, up to 1 over n. And here, we want to get a closed bound for this h of n. We want to show that h of n is really bounded closely by the natural log of n plus 1 and 1 plus the natural log of n. So n plus 1 is here, and then this one we can see that log of n and then plus 1 is equal to log of e times n. So this is en and this is n plus 1. So h of n is bounded by the log of these two numbers. Okay, the proof is actually very simple. We just need to have a little bit knowledge of the calculus. So here we define the curve. This is the red curve, and the red curve is the function of 1 over x. Now by looking at this red curve, we can define a lot of rectangles here, okay, of width 1, so that if it is for the x value of 1, then it will hit the point 1 over 1. If it is for the x value of 2, it will hit the point 1 over 2, and so on and so forth. Now notice that each of these rectangles here has a base width of 1. So the area of the first one is exactly 1. The area of the second one is exactly 1 over 2, and so on and so forth. So if we produce n rectangles like this, then it will be the harmonic number that we are interested into. And then we will see that the rectangle area will be more than the area below this curve of red curve. So by establishing this as a fact, then using some calculus technique, so we will have h of n is the rectangles, and then this is the integration of 1 up to n plus 1 of this function of 1 over x, and then we will see that this is the area under the curve, and then after evaluation it is equal to log of n plus 1. So we will see that h of n will be greater than or equal to log of n plus 1. Okay, and similarly we can do the same thing, but this time the rectangle is shifted, or you can see that we start from this 2, and when we hit the point, we draw a rectangle. Instead of drawing it rightward, we draw it leftward. So in this case, we will see that the area covered by these green rectangles will be smaller than the area under the curve from 1 up to this n. So the area of the green rectangles is exactly h of n minus 1, because we have omitted the term 1. And then the area under the red curve here from 1 to n is log of n. So in that case, we have established the fact that log of n is greater than or equal to h of n minus 1. So that's why we will have 1 plus log of n will be greater than or equal to h of n. So this is the closed bound for the harmonic number.